Uncertainty principle means Heisenberg's uncertainty principle. The physicist Werner Heisenberg in the year 1927, he formulated this principle, which is popularly known as Heisenberg's uncertainty principle. Yes, his name is also used with the phrase uncertainty principle. So this law, this law is applicable in the field of quantum mechanics or quantum physics. There are certain pairs of observables or variables which are called conjugate variables or conjugate observables, such as position and momentum, such as spins, such as spin along the x-axis and spin along the y-axis. So this becomes one pair. Electric field and magnetic field, this is another pair. Angular position and angular momentum, this is also another pair. Okay, so there are so many conjugate pairs of variables. So this law means uncertainty principle. This principle is applicable for these pairs. And as an example, always the pair which is known as position and momentum, this is mentioned. But there are other pairs also, other pairs of variables. So what is the law or what is the principle? The principle is that it states that means Heisenberg's uncertainty principle states that the limit to which certain pairs of physical properties such as position and momentum can be known simultaneously. What is the meaning of this? Meaning is there is a limit. This phrase has been used here. There is a limit. Means you cannot achieve arbitrary accuracy. It is not possible for anybody to achieve arbitrary accuracy in the measurement of the observables. If you are talking about, means if you are considering the pair position and momentum, when you are measuring the position to a high degree of accuracy or a high level of accuracy, then the other, means the complementary part, momentum, the accuracy in the measurement of momentum will be less. If it is high, if position is high, then momentum will be less. Means I am talking about the precision of measurement. If precision of measurement of one variable is high, then the precision of measurement of the other variable will be less. And that is the uncertainty principle of Heisenberg. So there are two kinds of interpretations. One is called Heisenberg's uncertainty, Heisenberg's interpretation. Another one is Niels Bohr's interpretation. You know that Niels Bohr, he is also a famous scientist. He is a famous physicist in the field of quantum mechanics, and according to him, this is the law of nature at the quantum level. This is his interpretation, means Niels Bohr's interpretation. That uncertainty principle, this is a key feature of nature at the quantum level. And the physicist Heisenberg, he initially formulated this law for the measurement as a consequence of the measurement problem, okay, in quantum mechanics. Heisenberg formulated this law as a consequence to the limitations with which measurements can be made in the field of quantum mechanics, measurements of the observables, okay. But according to his interpretation, what is his interpretation? Means I am talking about Heisenberg. What is his interpretation? According to him, whenever you are measuring one variable with, means whenever you are making an attempt to measure one variable, you are physically disturbing the other variable. and this disturbance causes the accuracy of the measurement to be at lower level. Means lower degree of accuracy can be achieved. Lower degree of accuracy can be achieved if you are measuring, if you are disturbing that variable, when you are measuring the other variable. Okay. Once again, I am trying to make you understand the same thing, that whenever you are trying to measure one variable, such as position, at that instant you are disturbing the other variables such as momentum. And since you are disturbing that thing, that's why you are getting less accurate result. And this happens due to the wave-like nature of particles. You know, dual nature means wave-particle duality. I think you know this thing. And according to Heisenberg, this happens due to the wave-like nature of the particles. So these are interpretations. And you know, quantum technologies such as quantum communication is there, quantum computing is there, quantum cryptography is there. So as an engineer or technologist, whenever you are going to interpret some quantum phenomena, if you do not understand Heisenberg's uncertainty principle properly, then you won't be able to interpret the phenomena observed in the field of quantum mechanics. And as an engineer or technologist, whenever you are going to develop some new technology, you have to understand this principle without any doubts. If you do not understand this principle clearly, okay, then in that case, I think you won't be able to design any new technology. Anyway, so this was all about Heisenberg's uncertainty principle. Once again, I want to mention the same thing, that whenever this law is analyzed or discussed, the Heisenberg's uncertainty principle, only position and momentum, these two variables are talked about or are discussed. But there are other pairs of variables also, such as electric field and magnetic field, spins, angular position and angular momentum, like that. Okay. So there are many other pairs also present in the analysis of quantum mechanics phenomena. Okay, so this was all about Heisenberg's uncertainty principle. This is the end of this video. Thank you. Thank you for watching this video.